Hello guys, so welcome back to our online organic chemistry lecture series, and this time we'll look at how to give names for organic molecules containing more than one functional group. And this will be the last topic to conclude our nomenclature of organic compounds. Alright, so naming monofunctional organic compounds is relatively straightforward as what we did in the previous lectures. However, sometimes when we are faced with organic molecules containing more than one functional groups, then there could be a problem. Example, if we have this molecule, we can recognize that this molecule has two functional groups. So we have here a ketone and a carboxylic functional group. So should we name this one as a ketone or a carboxylic acid? Which functional group will be our basis? In the second example, we have a triple bond and we have the presence of halide. So should we name this one as an alkyne or an alkyl halide? In this third example, we recognize that there's a presence of ketones and hydroxy functional group. So should we name this compound as an alcohol or a ketone? And lastly, this molecule, should we name this as an alcohol or an alkene? So in general, these organic molecules would require a certain set of rules that we should follow in order for us to give the correct names. In IUPAC nomenclature, the naming for polyfunctional organic molecules have four parts. So we have the suffix, the parent, the prefixes, and the locans. All right, so the first part of this lecture video, we will try to discuss the different parts of the polyfunctional organic molecules, and we will start our discussion with the functional group precedence, or how we choose the suffix for a polyfunctional organic molecule. All right, so for polyfunctional organic molecules, we have principal groups and subordinate groups. So for principal groups, they can be cited either as prefixes or as suffixes. Now, there can only be one suffix for a polyfunctional organic compound, and we have to select or choose this functional group of highest priority. Now, the highest priority functional group is known as your principal group. Now, the other types of groups are called subordinate groups, and these are only cited as prefixes. Within the principal groups, the order of priority has been established with the proper suffix given to compounds determined by choosing the principal group of highest priority. So we have here a table that tells us the different ranking of the functional groups. So we would see here that the carboxylic acids rank highest and the alkanes rank the lowest for principal groups. If we use carboxylic acids as the principal group, this means the molecule should end in the suffix oic acid or carboxylic acid. Now, if carboxylic acids are used as prefixes, then we use the prefix carboxy. All right, so let's take a look at some of the examples and we'll explain this table. Okay, so let's look at this specific example here. So we have this molecule and we could recognize that this molecule contains two functional groups. We have ester group and we have a ketone group. So if we use the table, we would recognize that the esters rank higher than your ketones. Okay, so this only means that we should name this molecule as an ester and not a ketone. So the name for this one will be methyl 4-oxopentanoate. So for this one, our goal is just to identify the principal groups and apply this table. Okay, so for this molecule, we would recognize that this one has the amino group and an alcohol group. So if we refer to our table, the alcohols rank higher than your amines. So the naming for this molecule will be as an alcohol and not as an amine. So in this case, the NH2 group is used as a prefix, and for amines, the prefix will be amino. Now, if you look at the third example, so we have here a ester group, and we also have here a CHO group, and this is referred to as your aldehydes. Now, if we have aldehydes versus your esters, obviously your esters rank higher than the aldehydes, so this molecule will be named as an ester and not as an aldehyde. If we treat your aldehyde as a prefix, then aldehydes will be named as oxo. Now, this is the same thing for ketones as in the first example. And lastly, if we look at this molecule, we have three functional groups. So we have carboxylic acids, your alcohols, and your amides. Now, if we look at the principal groups, the carboxylic acids rank highest as compared to your amides and to your alcohols. So in this case, this molecule will be named as a carboxylic acid. Now, what happens to your alcohol and to your amide groups? These groups will become substituents. An alcohol group, the prefix that you will use is hydroxy, and for an amide group, the prefix that we shall use will be carbamoyl. So the name for this one will be 5-carbamoyl for hydroxypentanoic acid. So we now know which functional groups to choose if we are given a polyfunctional organic molecules. Now, when the parent or the base name of a polyfunctional organic compound is identified, the next thing that we have to do is to select the parent. Now, if the principal group of highest priority is part of an open chain, then the name of the parent is that of the longest chain containing the largest number of functional groups. Now, let us try to consider these two isomeric molecules. In this case, we have an amide group and we have a aldehyde group. And we know that amides rank higher than your aldehyde. So this molecule will be named as amides. This molecule is a straight chain, so we have to select the parent, and selecting the parent means we have to choose the longest chain that contains the most number of principal groups. So we recognize that this one is the parent and this one is subordinate group. So if I will choose the parent for this molecule, I will select the longest continuous carbon chain that also includes this part of the molecule here. So this one will be carbon number 1. This one will be carbon number 2, 3, 4, 5, and 6. So since this one has 6 carbons, the parent will become hexanamide. Now, if this is the principal group, then the numbering should start at this carbon atom. So at the 5th carbon, we have a substituent, which is a methyl group. And at the 6th carbon, we have an aldehyde. Now, aldehydes and ketones, the prefixes that we use is oxo. So in this case, the molecule's name will be 5-methyl-6-oxo-hexanamide. Now, let's try to consider this molecule. Again, we have here the amide group and we have the aldehyde group. The amide group is higher priority than the aldehyde group, so this is the principal group of the molecule. Now, if I select the parent chain, then I should remember that the parent chain should be the longest chain, but at the same time, it should contain the largest number of principal groups. So if I number this chain, I will start numbering from this carbon as number 1, this is number 2, number 3, and number 4. Okay, so this one will become a substituent and it is known as propyl. So the parent name for this one is butanamide. And at carbon number 4, that is an aldehyde group, and this is given by the prefix oxo. So the final name will be 4-oxo-3-propyl butanamide. Now, how about if the highest priority group is attached into a ring? So in this case, if the highest priority is attached to a ring, then the parent name is that of the ring system. So we'll try to explain this using this example. So let's try to consider these two molecules here. These are isomeric compounds. This one is named as benzonitrile because the functional group CN is connected directly to the ring, and this one has a higher priority as compared to your ketones or to your alkyl halides. In contrast, if you look at this molecule, the nitrile group is connected to an open chain, which is your CH2. So the parent name will be acetonitrile. The correct names for these molecules are 2-acetyl, 4-bromoethyl benzonitrile, and 2-acetyl, 4-bromophenyl acetonitrile for this molecule. All right, let's try to consider the other two examples in this case. So we have here these two isomeric compounds again. Let's try to look at this one. So for this molecule, we have a carboxylic acid group and we have a aldehyde group. So in this molecule, we have a ketone group and we have a carboxylic acid group. Now for both molecules, the principal functional group is the carboxylic acid group. Now the only difference for this one is that the carboxylic acid group for this molecule is connected directly to the ring. But in this molecule, the carboxylic acid is part of the open chain. Now, how do we give name for this? For this molecule, the full name for this one is trans 2,3-oxopropyl cyclohexane carboxylic acid. So the parent is cyclohexane carboxylic acid because the carboxylic acid group is directly connected to the ring. But in this case, the parent is not the ring, but it is the open chain. So the final name for this one is 3,2-oxocyclohexyl propanoic acid. So this will be carbon number 1, this is carbon number 2, carbon number 3. And lastly, let's look at how to give prefixes and locants. All right, so with the parent name and the suffix established, the next step that we have to do is to identify and give the numbers or locants to all substituents on the parent chain or in the ring. Now, these substituents should include your alkyl groups and all functional groups other than the one cited in the suffix. All right, let's try to consider this molecule. So we have here carboxylic acid, your double bond, and your ketone. So in this case, the principal group will be your carboxylic acid, so the naming of the molecule will be as an acid. However, we have here a double bond. So if we have a double bond or if we have a triple bond, we can also use them as a suffix. That is the exception to this rule. So in this case, this one is named as an enoic acid. So how do we number the parent chain? So since this is the priority group, then the numbering should start at this carbon. And we should select the longest chain that includes most of the functional groups. So in this case, this is carbon 1, this becomes carbon 3, this becomes carbon 4, this becomes carbon 5, this becomes carbon 6, and this becomes carbon 7. So notice that carbon number 2 and carbon number 5, we have methyl groups as your substituents, and we have 3 of them, so we use the multiplier tri. Now, at carbon number 4, to denote that this carbon is a ketone, then we use the prefix oxo. And the letter E here just tells us the configuration of the double bond. All right, so once the parts have been identified, for example, the parent, the prefixes, locants, and the principal functional groups, it is now time for us to write the full name of the organic molecule. Right, so the first thing we have to understand is the order of prefixes. All right, so the name of the substituents for polyfunctional organic molecules should always be written in alphabetical order. Now remember, if there are substituents that are the same, then we have to use the multiplier such as di and tri. Now remember as well that these multipliers are not used for alphabetization, but the prefix iso is used for alphabetization. All right, let's try to look at this molecule. Again, looking at this molecule, the first thing we have to do is to look for functional groups and decide which of these functional groups is the principal group or the priority group. So in this case, we have the hydroxyl group and we have the amino group. Now, hydroxyl groups rank higher than your amino groups, therefore this molecule will be given the name as an alcohol. Now, in choosing the parent chain, then the rule that we follow is that we have to choose for the longest chain that contains most of the principal groups. And in this case, this will be the parent chain. So I will number on this carbon atom because this side is nearer to the hydroxyl functional group, which is the priority group. So this one is carbon 1, this becomes carbon 2, this becomes carbon 3, carbon 4, and carbon 5. So at carbon 2, we have the hydroxy group, and the suffix that we use is pentan-2-ol. Now we have the NH2 group connected to carbon number 5. So this will be 5-amino. And remember that at carbon number 3, we have a methyl group. So the final name for the molecule is 5-amino 3-methyl pentan-2-ol. Again, please remember that the substituents must be arranged in alphabetical order, and do not forget to write the locants of the substituents. All right, so the next thing we have to do is to decide when we use hyphens in writing single or multiple words. So the general rule here is to determine whether the parent is itself an element or a compound. If it is, then the name is written as a single word. If it isn't, then the name is written as multiple words. So we have the following examples to illustrate this rule. Okay, so we have here dimethyl magnesium. Now, this compound is named as a single word because magnesium is an element. Now, if we move on to this example, this molecule is named as isopropyl 3-hydroxypropanoate. Take note that isopropyl here is separated from the parent, which is 3-hydroxypropanoate. So this compound is named in 2 words. Right, so let's try to consider this molecule. So this one is named as 4-dimethylamino-pyridine. Now this compound is named as a single word because pyridine is a compound. And lastly, if we look at this one, this molecule is named as methyl cyclopentane carbothioate. And take note that this compound is named in 2 words because your cyclopentane carbothioate is not a compound. We have to know how and when to use parentheses. So parentheses are actually used to denote complex substituents just to avoid ambiguity in the naming. Now, the expressions in parentheses are not usually set off by hyphens from the rest of the name. All right, so let's try to consider the following molecules. So we have here this isomeric benzene derivatives. So in the first example, this is named as chloromethylbenzene because the ring has 2 substituents connected to the benzene ring. Now, in this case, we name this one as chloromethylbenzene because the ring has only 1 complex substituent. All right, so if we look at this third example, we notice that this is a dicarboxylic acid. So we have dioic acid as a suffix. And to denote the substituent, we use a parenthesis because the substituent is complex. So the final name for the molecule is 1-methylpropyl pentane dioic acid. All right, so in the previous examples, we've mentioned that we have to decide the principal group for polyfunctional organic molecules. And for polyfunctional organic molecules, there should only be 1 suffix. However, we have exception to this rule. This exception occurs for molecules containing double bonds and triple bonds. So if we have double bonds and triple bonds aside from other or functional groups in the molecule, then it is possible for us to have 2 suffixes. So for example, so we have here this molecule, which is an alcohol, and we have here an alkene. Now we will name this one not only as an alcohol, but also as an alkene. So in this case, we name this one as pent 4N1-ol. So we have to indicate that this molecule contains your double bond, which is at carbon number 4, and you have an OL here to denote that this molecule is an alcohol as well. Okay, so this one is simply a monofunctional organic molecule, and this one is named as 1-pentene. For alkynes, we use the prefix "in" and the suffix "-ine". So for example, if we have a monofunctional organic molecule containing a triple bond, this one is named as pent-2-ine. Again, we number at the end nearest the triple bond. If we have this molecule, we notice that we have two functional groups here. So we have a triple bond and we have a amino group. Now between the triple bond and the amino group, the functional group with the highest priority or the principal group will be the amino group. So this one will be named as an amine. We have to include in the final name. So the name of the molecule will be but2-in-1-amine. All right, so let's try to consider molecules containing only alkenes and alkynes and no other substituents of higher priority exist in these molecules. Okay, so how do we give names for this one? So if we have organic molecules containing double bonds and triple bonds, they are named as enines, or we have "in" and we have here the suffix "ine". So we have to indicate, in this case, the location of the double bond and the location of the triple bond. So how do we apply this? So we have to remember that their chain will be numbered so as to provide with the lowest set of locants, and we have to arrange the substituents again in an alphabetical order. So in this case, let's try to consider this molecule. So we have here a 5-carbon molecule, and since it has a triple bond or an unsaturation at the first carbon, then I will start numbering in this carbon because this will provide me with the lowest set of locants. So in this case, this is carbon 1, 2, 3, 4, and 5. So this is 5. So we will know that a 5-carbon atom is pentane, but since we have an enines, then we just have to use this name. So in this case, the triple bond is at carbon number 1 and the double bond is at carbon number 3. So the naming comes pent-3N1-ine. All right, so let's take a look at this last example here. So what if, for example, we have a molecule in which your double bond and triple bond occurs at equal distances from the end of the chain? So which one is the priority? So in this case, these ones are still named as enines, but the priority goes to your double bond, meaning we have to number the chain at the double bond side end of the molecule. So in this case, this will be carbon number 1, carbon number 2, 3, 4, and 5. So the name for this molecule will be pent-1-in-4-ine. All right, so let's try to look at these molecules again and just highlight some of the important things that we've learned on how to give names for our polyfunctional organic molecules. So let's take a look at the first examples. So in this case, we have a carboxylic acid group and a ketone group. In the table that I've shown you previously, the carboxylic acid group is higher priority than the ketone group. So this molecule will be named as an carboxylic acid. And since this is the principal functional group, then numbering should start at this carbon. So this is carbon 1, 2, 3, 4, and 5. Remember that the parent chain must contain the most number of carbon atoms, and at the same time, it should also contain most of the functional groups present in the molecule. Okay, so at carbon number 4, we have the carbonyl carbon for a ketone, and this one is denoted by the prefix oxo. So the name of the molecule will be 4-oxopentanoic acid. In the second molecule, we have here your bromo your chloro, and your nitro. Now take note that these substituents are subordinate groups and they are used only as prefixes. So in this case, this molecule is treated as an alkane. So the name for this one will be 1-bromo 4-chloro 3-nitroheptane. Again, we should number the chain in such a way that the substituents must have the lowest possible set of locants. All right, let's take a look at this third example here. So we have here a cyclic molecule which has a ketone functional group, and you have here an alcohol. So between a ketone and an alcohol, the priority group will be your ketone. Now, since this is the priority group, then we should number the ring in such a way that the alcohol group will still have a lowest possible locant. So in this case, I will start numbering up this carbon as 1 and this carbon as 2. If the alcohol is used as a substituent, then the prefix that we use here is hydroxy. So the name of this molecule is 2-hydroxycyclopentanone. Okay, so let's take a look at this fourth example here. So we have here what we an ester, and we have here a thiol. So the name will be ethyl for mercaptobutanoate. Now remember, for in naming esters, we have to name the alkyl group first, followed by the acyl group. Now, if you look at carbon 4, we have a thiol group. Since this is treated as a substituent, the prefix that we will use is mercapto. So the final name for the molecule is ethyl for mercaptobutanoate. Okay, so let's look at this fifth example. So we have here a double bond and a hydroxyl functional group. So between these two, the alcohol ranks higher than the double bond, so this molecule will be named as an alcohol. But we have an exception to this rule, so we will include the double bond in the suffix. So in this case, we have pent-4-in-1-ol. Okay, so lastly, let's take a look at this example, and we've noticed that we have a triple bond, and you have here your halogen. So this one will be named as an alkyne. So the name for this one is 5-chloropent-1-ine. Obviously, I will start numbering up this carbon because it has the triple bond. And that's how we give names for polyfunctional organic molecules.